there, scientists! Last time we compared solid and liquid water. Today, let's look at different water temperatures. Now, we've talked about how when water freezes, it expands. But remember, we also talked about those molecules moving more quickly or more slowly, depending on if they're getting hot or cold. So let's do some experiments with that. We still need some evidence to show that that's actually happening, don't we? So, I have here 2 containers. I'm going to pour some room temperature water into one container. Now, you may be thinking, well, I don't know if your water is really room temperature. You're on camera. Well, we need evidence again, don't we? So if we want to measure temperature, we use a thermometer. So we're going to plunk in our thermometer here, and we are going to measure that temperature, making sure it's below water level, so it's actually taking its temperature. We'll check that in a moment. All right, room temperature is usually around 70 degrees Fahrenheit. Oh, it's a little toasty in this room. It looks like it's about 75 degrees Fahrenheit. That water is about 75 degrees Fahrenheit. Now, I have some really hot water. I boiled it previously, and then to get ready to teach some science, I put it in this really good thermos. So this should be really hot water. Now, your observation should be able to tell you that it's really, really hot when I pour it out. I'll try to get about the same amount. I don't know if you can see it from there. I'll hold it up for you so you can see. You can make some observations. See, it's steaming. It fogged up the sides of the glass a little bit. That's because those water molecules are moving so quickly that they moved so quickly they changed into gas, they evaporated, but when they touched the side of the cool glass, they changed to liquid because they cooled back down. So some of it's evaporating out, but some of it's touching the glass on the way and actually becoming condensation when water changes from a gas to a liquid. Now, I keep telling you that these molecules are moving more slowly or more quickly depending on if they're hot or they're cold. You need some evidence, don't you? Yeah, you need to see the real thing. So what I'm going to do is I'm going to take some food coloring here. I have blue for my cool water and red for my hot water, and I'm going to do my best to drop 1 drop into each at the same exact time. And we're going to have a race. We're going to see which container manages to mix the food coloring on its own faster. When I say on its own, it's because, remember, the water molecules as a liquid are moving around, but they should be moving more slowly here and more quickly here. When I drop the food coloring on the top of the water, then the molecules will do the carrying around and the mixing because they're moving. So let's see. Now, we'll hold it up for you so you can look more closely and you can see which one is moving more quickly. Here are our glasses of water against a backdrop so that you can see more clearly. It looks like the red is moving more quickly. Why is that? Remember, those hot water molecules are moving around more quickly than the cold water molecules. So the hot water molecules are carrying around the red food coloring and mixing it in more quickly. Now, what if we went and we took solid water and we dropped food coloring onto that? What do you suppose is going to happen then? Well, let's try that out, scientists, shall we? I have another ice cube here. I'll put it into my little trusty cup. And let's use some green food coloring this time. I'll put 1 little drop on there. You might want to make a prediction first and think about what would happen if you put a drop of liquid food coloring on your solid ice cube. Are the molecules in your ice cube moving? They're holding still. They're holding that expanded out structure, right? Melting a little bit because it's warm in here. Well, let's see. Oh, it looks like it slides right off. That liquid wants to move, but the solid ice cube, it's not moving. Now, eventually, what if I check this cup a couple hours later? What do you think is going to be in that cup? In this nice warm room? Will that ice cube stay solid? Nah, the warm temperature is going to help it change. Remember, the molecules are going to move a little bit more quickly. They're going to change from a solid to a liquid. And then if I leave this for a very long time in a nice warm place, eventually all of that heat's going to make all that liquid change into gas because those molecules from the liquid will move more and more and more and more quickly, and they'll move so quickly they'll change into water vapor. Maybe we'll check that again later. See you next time when we will explore more water matters.